Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone, welcome back to the playlist on computer vision. The last lectures we discussed about thresholding, the concept of thresholding and canny edge detection in OpenCV. From today, we'll be starting a very important concept in OpenCV which is known as contour detection. So basically, the first question that comes to our mind is what a contour exactly is. So contour is nothing but like suppose you have been given an image and the image has been the image consists of several points. And when you join that several points together, the plane you get is actually the contour. So anything that has been composed of several points, and when you join that points together, the thing we actually get is contour. So if you are thinking that contour or edges are just the same thing, then you may be a little bit mistaken, as these both the two are different, and we actually have different use cases for edge detection and contour detection. So contour is basically used for detecting shapes. Like let's say you have been given an image and you want to find whether the image contains ball or not. So like ball is maybe round in shape, or maybe as you can say oval in shape maybe. So like contour detection is used in these type of cases to actually detect the shape of, like whether a particular shape is present in the image or not. So like we will be seeing the practical examples of contour detection in the next video lectures. We will be having a hands-on coding exercise using contour, but for the sake of it and like in the interest of time, let's get started on contour detection and see like what basic contour detection is all about. So what I will do is I will go up and find my Jupyter notebook. I will import numpy as np, and I will also import cv2. And what I will do is I will store my image in the variable called img cv2.imread, and this should be trial.jpg. I hope you already know what the trial image is. The same Pokemon image that we have been using for a long time now. Now, contour detection best works on this binary images or grayscale images. So what we are required to do is that we are required to actually like convert the image into grayscale image. But before that, I will store the trial image again into one of the new files, which is known as image, because you will actually get to know the reason later. So I will store this here as well. And now I will convert the img into the grayscale image. So I will use the convert color function. So img comma cv2 dot color, and this is bgr to gray, right? So once this is done, now what I will do is that I have a function which is known as cv2 dot draw contours, and I will actually use that function to draw contours around my like around the region. So every plane or every point that has been connected will actually be visible to you. So what I will do is that I will call the function cv2 dot draw contours, and in the draw contours you have like the following parameters. The first is the image, the second is the basic parameter, like the one we actually use, which is ret underscore tree, retar underscore tree, and the third parameter which we use in contour detection is actually the chain approx null method. So cv2 dot chain approx null. So you don't need to know what the last two parameters are, because in all of the lectures or anywhere you will see actually will be using these by default parameters as well. If you're interested, you might know the maths behind it by researching more upon this. But like for the sake of practical understanding, these two will always be used in draw contours method. And draw contours method will return me two variables. One is known as contour, or I will say that CNT, and other is not important to me, so I will just give it underscore value over here, and I will run this piece of code over here, and it tells me that we require a color. Okay, so this is not the draw contour, but I would actually use the find contours first. So this is find contours and not draw contours. Draw contours will actually draw contours around an image, but find contour is the method by which we will actually find contours around the image, or maybe the planes, or as you can understand. So just need to change the function from draw contours to found contours, and then I will run this. So this runs successfully now, and what I will do is that I now need to draw these contours onto my image. So what I will do is I will open up a new variable which is known as y, and I will use the function cv2.draw contours, and in this, first I will pass on what image I have to draw the contours. So I will be using the n image over here because my previous image has been converted to a grayscale image, and if I use the grayscale image, you won't actually like see like what actually is happening or how the contours are actually drawn. So because I want to preserve my color image, I actually have stored this the image into a new variable which is known as img, and I am passing the same over here. And then what I will be doing is I will pass the cnt which we have got from find contours over here, and then we have the parameters such as how many contours do we want. So I want all contours to be drawn, so I will pass in -1 over here. And then there is this like the color of the contours to be drawn, so I will prefer a green color contour, so it's 0,255,0 in bgr format, and I want the thickness to be, let's say, 5. I will go ahead and like run this piece of code, and now I will show you like how these contours exactly look like. So I will use cv2.im show and window comma y, then cv2 dot wait key 0, and then cv2 dot destroy all windows, right? And I will run this piece of code, and as you can see, this is how your contours exactly look like. So you can see, like, can you see these green dots appearing on the borders? So these are basically the points. So these points are connected, and then you exactly get the like connection of these points exactly make up the contour. So the basic difference between contour and edge is that in contour every point should have the same intensity, whereas the case is not the same in edges part. So these all are contours actually which the image has actually detected. So these are the points, and by connecting these points you basically get a shape, and this is how you actually detect shapes in an program in OpenCV. You see also the green color appearing back over here, like on the border of the images, because these are the points as well, and connecting these points we get a square. So this is how like contour detection works in OpenCV. We will see the practical example of it in the next few video lectures. So I hope you like learned something interesting and important from it, and you enjoyed this video lecture. See you in the next one. Thank you.